Let's now imagine a scenario. You're working for a car company, Sunset Motors, who wants to add a chatbot to their website to answer some of customers' most frequently asked questions. They have asked you to create a prototype of this FAQ chatbot. So to do this, the first thing we're going to need is some data about the company. Here we have our Sunset Motors context, and if we print this out, you can see it's some really important information about the business, such as when it opened, where it is, and what kind of cars it sells. We can then create a function which we'll call FAQBot, where we can feed it a question. The model will then look at the context we've provided and provide the correct response. This will be an excellent prototype for our FAQ chatbot for the website. So the first thing we want to do is define the function FAQBot, and the input to this function will be the question we want to answer. We'll then provide our context, so this is the Sunset Motors context. We'll then need to encode the question and the context. So we'll take our input IDs from tokenizer.encode, and we'll take our tokens, where we convert these IDs back to their token values. We then want to create our segment embeddings. So the first thing we need to do is find the separator token within our list of input IDs. So from the input IDs.index, we're looking for the tokenizer and the separation token ID. Once we've got this, we can use this to compute the number of tokens in segment A and the number of tokens in segment B. So for the number in segment A, we take the separation ID plus 1. And for segment B, we take the length of the input IDs and take away the number of segments in segment A that we just calculated. We can then create our list of segment IDs, so we'll do zeros repeated for each token needed in segment 1, and ones for each token in segment 2. We can then feed all this into our model. So we'll take our output and then run model, and we'll convert our input IDs into a torch tensor and our segment IDs, which will also convert into a torch tensor. We then need to create the answer start and answer end positions. So from the outputs, we convert these into torch.argmax, and then we can find our answer start and where our answer should end. We then tell our function that if the answer end is after the answer start, so essentially is the start of the response going to be tokens ahead of the end of the response, then we can print our answer, and our answer is the tokens between the start position and the end position plus 1. If this is not the case and it looks like the end token is going to come before the start token, then we know something's gone wrong here, so we can print a message instead of providing an answer. So we'll print, "I'm unable to find the answer to this question. Can you please ask me another question?" In our function, we also want to tidy up any responses we might get, because sometimes hash values are left in just because of how the data is tokenized. So we want to create our corrected answer. And then for each word in answer.split, so we're taking each word in our answer. And then if the word contains these hash values, we can just edit this and correct the answer by removing these hash values. We then return this corrected answer. So we've now got our FAQBot function. Let's ask it some questions and test its knowledge. So we can ask, where is the dealership located? And our model has returned the answer Crestwood. Let's try with, what make of cars are available? And again, we can see we've got the correct response of Ford, Toyota, Honda, Chevrolet, and BMW. Our model is able to reference the context we gave it to answer these questions. Let's try one more. So how large is the dealership? And again, the model's got this right at 10 acres. You've successfully created a prototype FAQ chatbot. You can imagine just how powerful this could be if you combined it with the LangChain framework to bring in even more custom data. You can find more information about this in the dedicated LangChain course.